Now, these polynomial inequalities, remember, we're going to involve a number line, right? What do we need to do? Take your hat off, Gabriella. What do we do?
You can factor that by
We need to factor it. Now, the last problem we did last time we were together, we had to use synthetic division. Do you remember that?
Mm-hmm.
Could you use synthetic division on this one?
Yeah.
Absolutely. Do you have to? No. Because, as Brennan said, it factors by grouping. Now, if you notice that, then you can factor by grouping. If you don't notice it, then you're going to do synthetic division, because one way or the other, you got to get it factored. So, factoring by grouping, does that look okay to everybody? You see what I did?
Yep.
What can I take out of these? -4. And remember, if you're going to factor by grouping, these have to match. If they don't match, either you messed up or it doesn't factor by grouping. They have to match. They do. Now what? That factors more easily difference of squares, x plus 2, x minus 2. Now, do you remember what you do next? We got to get it factored.
So all equal to 0.
So, yeah, we're going to draw a number line, and by setting them all equal to 0, we will get 3 dots. And where will the dots be? -3,
-2 and 2.
-2, and 2. Now, it just worked out. They came in that order, but please be careful. When you put them on the number line, you got to get them in the right order. It won't always be in the order they come in the problem. They got to be numerically correct. All right. Now, does anyone remember what we have to do next? Huh? Well, yeah, we got errors.
Thank you, Sam.
Pick a number that's not one of those. 3. 3 is a great number. Would everybody agree 3 is down here?
Yep.
So I'm going to put 3 into my parentheses, put the number 3 in, and I get 6 times 5 times 1, which is 30. Then I ask myself the important question. Is 30 greater than 0?
Yes, ma'am.
Yes.
Change that for
That means wherever I got the 30, which is down here, that gets shaded.
No, the alternates.
Now, if that piece got shaded, then this one
Not shaded.
won't be, but this one
Will be.
will be, and this one won't be. Now, that's just a little shortcut to save you from having to pick another number and plug it in. You have to pick some number somewhere. It wouldn't have to be 3. It could be anything except these. But once you figured out that got shaded, then yes, no, yes, no. So then we got to write our answer. So we're going to write it as a set, which would look like this. Or we're going to write it with interval notation, which would look like that. Or it's a union symbol, and in set land that means or. Okay? Now, next problem. It looks different. Okay. Actually, we can't get rid of the denominator. That is such a good guess, but it doesn't work, and here's why. Could this guy right here, x minus 3, could that be a positive quantity? Yeah, but could it also be a negative quantity?
Yes.
Yeah, and in an inequality, it matters whether it's positive or negative, because if it's negative, I have to switch the sign. So if I don't know if that's positive or negative, then I don't know what to do with that sign, and therefore I can't do the problem, because I don't know if it's negative or positive. So I wish you could do that, because it would make life so much easier, but you can't. So here's what you do instead. You put 2 dots on the number line, and the dots are going to be at -1 and 3. Now look carefully at the problem. Does it make sense to you where I got -1 and 3?
Yes.
Where I've been getting all of them, right, from my x quantities? Now, there's only 2 dots on the number line. There's nothing squared or weird about the problem. It's a less than 0. Where do I shade less than 0 if I only have 2 dots on the number line? Between. So your answer very simply is all the numbers between -1 and 3. Now, I know it gets a little overwhelming because there's all these cases of things. You don't have to ever do the problem that way. Pick a number. What if I picked 5? If I put 5 in, I would get 6/2, right? Which is 3? Is 3 less than 0? No. So I don't shade that section. Well, if I don't shade that one, then I will shade this one and won't shade that one. So you can forget the shortcuts, in, out, all that stuff, and just pick numbers, if that's how you want to do it. Oh my goodness, look at number 9. What do you think we're going to have to do with number 9?
Factor.
We're going to have to factor it. So the top, +3 minus 3, and the bottom, +2 minus 2. I don't know if it's bad news or good news, but nothing cancels out, right? So that means on my number line, how do I know I'm going to be doing number line? Anytime it's an inequality, you're doing a number line. How many dots are going to be on this thing?
4.
4. Notice the order I put them in? Take your time and make sure they're on the regular number line order.
We're all shaded.
Now this is where things get wild and wacky. Shiloh says, Mrs. Ford, there's an or equal to. I am absolutely going to shade these. But I'm not going to shade these. Because what happens in my problem if I let x be 2? So I get a 0 in the bottom? Is that okay? No. So denominator dots, dots that come from the denominator dots are open, period. It doesn't matter what the symbol is in the problem. Any dot that comes from the denominator must be open. because the denominator can never equal 0. The top can, but not the bottom. That's one of those tricky little things that might cost you a fraction of a point. So I don't want you losing sleep over it, but denominator dots are open. Okay? Now, the good news is none of these factors look like this. That is really bad. That's when all bets are off and I have to try every single section. This problem is still going to alternate. There's a lot of sections, but they're still going to alternate. But I got to figure out, I got to start somewhere.
4.
So pick a number. 4 is fine. Pick a number out here. The number you pick can be anything except these. So 4 is fine. 0 would be fine. 2.5 would be fine, but I wouldn't pick it if I were you because it's a decimal. But any number is fine except these. So he said 4. So let's put 4 in. Now what do I get if I put in 4? I get 7 times 1 over 6 times 2. So I get 7/12. Now what question are you asking yourself?
Greater than or equal to 0.
Is 7/12 bigger than 0? Yes.
Cool.
So since it's a yes,
Shade it.
we'll shade it in. Now since we shaded in that one, we won't shade in this one. We will, we won't, we will. Okay? Now I gotta write an answer. It's 3 parts. X is less than or equal to -3, or between -2 and 2, or bigger than or equal to 3. So that would be one way of writing your answer. In intervals, you could say everything from -infinity to -3. Notice the bracket, solid dot, bracket. Or open interval from -2 to 2. Or interval from 3 to infinity. Why are there so many parts to the answer? Because there's so many dots on the number line. Oh, Jalen, it's not that bad, I promise. Open your eyes. Please show me what this is for. No, not yet. Okay, take a look at the next problem. Now, certainly it looks easier than this one, but there is something off about it.
There's a 4.
There's a
Then it's
4.
0.
And what has been the case in all of my inequalities? It's been a 0. So kids, having a 4 is not good. All right, so here's what we're going to do. We're going to subtract the 4 over to the other side. Now, does that make sense to you? When we are doing an inequality, we need to know if it's positive or negative. And the reference point for that is 0, not 4. I can't have 4, must have 0. Now, would you agree this is really 4 over 1? So you've got this thing minus this thing. I need to combine that into one giant fraction. How do I subtract fractions? Find the common denominator. Isn't that the way I subtract fractions? So my common denominator will be x minus 3. Since this one is over 1, whatever this is going to be the common denominator. So now, both of my fractions have an x minus 3 in the bottom. My goal was to write one fraction. So the denominator is going to be the common denominator, which is x minus 3. Now, what am I going to have on top? Now watch it. All this goes on top. So it's going to be x plus 2, and then minus 4x plus 12. Yes. Perfect. Minus 4x plus 12. Does that make sense to everybody? Now, let's collect like terms. So up on top now, I have negative 3x and 14 over x minus 3. Now my problem looks like the other ones have looked. There are going to be, I'm going to draw my number line, and there are going to be 2 dots on the number line. A dot that comes from the top and a dot that comes from the bottom. Now the bottom dot is easy. That's going to be 3. This one isn't so easy. So instead of guessing, figure out where to put that dot by simply solving the equation. Where does it equal 0? See, this one, that's what you did, but it was so easy you did it in your head and said, okay, I'm going to have a dot at 3. This one's harder. Where is that dot going to be? 14 thirds, which is 4 2/3. Now, it doesn't really matter. I can leave it as 14 thirds, but I have to know where to put it on the number line. The 3 goes here, and the 14 thirds goes here, because 14 thirds is more than 3, because it's 4 something. Everybody okay with that? Now, because we did all that arithmetic, this problem is a little bit different than the normals because it started out with a 4. So what I need for you to do is pick a number, any number that isn't these 2. 4. What did you pick? 1? Pick one, you know, that's an easy one to use. So 1 would be fine. What do I get if I put in 1? On top, I would get 11. And on the bottom, I would get negative 2. Is negative 11 halves less than 0? Yes. So I'm going to shade that in. I'm not going to shade that one, but I am going to shade that one. So my answer is, oh, wait. What about coloring in the dots? I didn't do that. This was an or equal to problem, right? But be careful. What did we say about denominator dots?
Yeah.
Always open. So the 3 will be open, but the other one will be closed because of the sign in the problem. Now I can write my answer. X is less than 3, or X is greater than or equal to 14 thirds. That would be one way of writing my answer. Or using interval notation. And remembering that the infinities are always open. I could write my answer that way. Okay, watching the clock, Tex. This isn't the lunch period, is it? No, good.
Stretching my head.
That is a hard problem, guys. Unfortunately, there's one of those on your test. So let's try another one. Number 11. Hang in there. You got this. Who remembers step 1? Subtract the 2. When you're doing inequalities, there's got to be a 0. So we don't have a 0, so we're going to make a 0. And when we subtract that, it's really 2 over 1. And we need to combine these into one fraction. So we'll need to get a common denominator. And since that's a 1, the common denominator will just be x minus 1. So we'll need to multiply this by x minus 1. So 3x plus 1 minus, be careful here, 2x plus 2. We're adding, wouldn't that be 1x plus 3? Does that make sense to everybody? Everybody with me up to this point? All right, we're ready to draw number line. Where are the dots going? Anybody lose that? I just noticed it. Where do the dots go on the number line? Look, here.
Why don't you just do -3 and 1?
We're looking there. Where do the dots go? -3 and +1. Sam, you're delusional. Look at the top dot. They get a dot from the top and a dot from the bottom. So it's going to be -3 and +1. Now, they're both going to be open this time. No need to worry. Pick a number, not either one of those. 2. 2's out here. So go back right here. Right here. We put in 2, what do we get? 5 over 1?
Which is 5.
Which is 5. Is 5 bigger than 0?
Yes, ma'am.
So we shade. Don't shade. Shade. So again, I keep writing everything both ways. You obviously have to just write one way, pick one or the other. How are we on that? Are we okay? We've got a few word problems to do. But don't panic. Guess what? You've done them before. Read this problem. Have we ever done this? Yes, she says with enthusiasm. What is our basic formula when we are mixing solutions together? Oh, this is semester exam material, folks. Oh my Lord. Pat? It's amount times percent plus amount times percent equals amount times percent. Boys and girls, we studied those earlier in the year. They definitely will be in the exam. You need to be able to do this. Okay? So remember, we have like 3 groups of 2. And these 2 added together make that one. And we got 12% and 15. And we're going to get 14%. Is this starting to come back to you?
Yes, it is.
Yeah, it's like X.
Yeah,
Oh, I see.
there's a 5 gallons in the problem. Where do I put the 5?
With the 15.
With the 15.
And then
So the 5 goes here.
minus half, so like for the 12 you put.
How
X,
much?
And then 14 you put X plus 5.
And this is gonna be X plus 5, yep. Forgot to remind you to have your calculators, but you're always supposed to have your calculators. By the way, I'm not drawing a number line. This is not an inequality, right? I'm just solving this equation. Please watch those decimals. If you have 0.14 and you subtract 0.12, it isn't 0.2, it's 0.02. So let's see, what is that, 2.5? I better double check. My decimals aren't very good. Embarrassingly enough. And the unit on that would be what? Gallons? We're almost done, guys. Hang in there. Whoop, I got another one. So amount times percent. Eight cups of 54% acid is mixed with some 84% acid, a 60% solution results. Well, this one's worded a little bit differently, things are a little bit different order, but isn't this the same thing?
Yeah.
Isn't this just gonna be 8 plus X? I got 2, is that right? 2 cups. I'm just doing regular algebra 1, subtracting 0.6x, subtracting 4.32, and then dividing. Okay, all right, you balls of fire, we have 2 more problems to do, and they are a different kind, and I honestly can't remember, but I don't think we've done these yet. Have we done the work problems? So read the question. Danielle can do the homework in 4 hours. If Zach helps her, it will take her 3 hours. How long does it take Zach alone? No, let's figure it out. When we've got a couple of people working together on a job, they're called work problems. And the formula, or the setup, is 1 over the first guy's time alone, so 1 over alone, plus 1 over alone, equals 1 over together. So these are the 2 individual people. And then this is their time together. So, Danielle can do the homework in 4 hours. So we start with 1/4. That's Danielle's time alone.
1/x.
Now I need Zach's time alone. Well, I don't know that, right? So that's x, so 1/x. So 1 over Danielle's time plus 1 over Zach's time will equal 1 over their time together, which is 3. So the setup is super simple. 1 over the first alone plus 1 over the second alone always equals 1 over their time together.
You're gonna get a negative here.
Okay? Now, how do we solve an equation like that has so many fractions text?
Oh, change
Do we solve like a proportion?
Well, if there weren't this plus sign in there, you could, but there's no cross multiplying here because of the plus sign. If I only had this, absolutely.
Change all sides.
Common denominator?
Multiply through by the common denominator. What is the common denominator between 4x and 3? 12x. So I'm going to multiply everything by 12x. That is the common denominator. Now, 12/4, that's going to cancel and make a 3. So I have 3x. The x's are going to cancel, plus 12. 3 goes into 12 and makes 4.
Subtract 1 over
So 12 equals 1x,
x equals 3.
and x equals 12 hours.
Oh,
Huh?
Zach must be a procrastinator.
Yes, exactly, the procrastinator. All right, one more quickly, here we go. Grant can paint the football field for 8 hours. Matt can do it in 6 hours.
okay.
How long will it take them to do it together? So we do 1 over alone plus 1 over alone equals 1 over together. All right? So read the question. Grant can do it in 8 hours.
So it'd be 1/8.
1 over 8.
1 over 6.
Matt can do it in 6 hours.
6.
Plus 1 over 6. How long will it take them to do it together? 1 over x. This time, that's what we're looking for, right? Their time together?
48 hours.
What is the common denominator between 8, 6, and x? Well, I heard somebody say 24x. I heard somebody else say 48x. Either one is fine. You are just going to multiply by something that will cancel out the denominators. So if you want to go with the smallest number and say 24, that's perfect because it will cancel the denominators. 8 goes into 24 3 times. See how that canceled that denominator? That's the point. So we have 3x plus what happens here? 4x equals 24. You must cancel all the denominators. We did that back in section 2.7. So, we have 7x equals 24, and x equals 24/7 hours. And that's it. Wowzy, woo, woo, woo. You are awesome. All right. Do I see you tomorrow?
Yes.
Awesome, thank the Lord. Then tomorrow we will start reviewing.
See, it's Thursday too.